In this video, we are going to discuss cbse 12th class expected model questions from coordination compounds. See now, from the coordination compounds from the last years onwards, they are asking only these model questions. They are asking only these model questions. What is a model question? First one means they will give complex compounds and they may ask that what their IUPAC name, central metal atom hybridization, geometry of the molecule, complex compound, and the magnetic behavior, coordination number, oxidation state of central metal atom. These questions they are asking every year. So therefore, if you are practicing these questions, maximum it will be repeated. So first you practice this question. From the coordination compounds, mostly they are asking that what questions from VBT theory, crystal field theory, as well as IUPAC nomenclature, isomerism. These four topics are sound enough, means you can get a maximum score from these coordination compounds, right? So these model questions you can take the complex compound, IUPAC name, hybridization, geometry, magnetic behavior, coordination number, oxidation state of central metal atom, you can calculate for these complex compounds. Next, another model question is they are asking that what explain the crystal field splitting in octahedral complex compound with an example. Okay, no, octahedral complex compound you can take and explain that crystal field splitting diagram, T2GEG diagram is there, no, that model question. That question you practice. Next, this model question. On the basis of crystal field theory, write the electronic configuration of D4 ion. Here I am writing D4 ion. Instead of this D4, they may ask D5 or D3, D2, anyone. Or mostly D4, D5 or D6. They may ask. If condition is delta naught is less than P, delta naught is greater than P. Crystal field splitting is greater than pairing energy. Crystal field splitting is less than pairing energy. Okay, this question is last board exam also this question asked. So practice this question. Next, they are asking another question, fourth question. Give the suitable example and explain the following: linkage isomerism, ionization isomerism, coordination isomerism. We should define this isomerism with an example. Okay. Next, this is most important model questions from that what isomerism. They will give one complex compound and they are asking that what geometrical isomers or isomers of the compounds they are asking. Maximum NCERT model questions only you practice, NCERT questions. So now this complex is given, geometrical isomers they are asking. Cis trans we have to write. That is fifth question. Next, sixth question. What type of isomerism is exhibited by the following complexes? What type of isomerism? That means it is undergoing ionization isomerism, linkage isomerism, coordinated isomerism, okay, optical isomerism. We have to write what type of isomerism these are exhibiting. Okay, practice these questions. What type of isomerism? Next, write the structures and the names of all the stereoisomers of the following compounds. They will give complex compound, then we have to write its structure and IUPAC name. Names of all the stereoisomers. Okay. Next, another one is draw the structures of FeCO5, CO2CO8, Mn2CO10, nickel tetracarbonyl. These questions. This is top 8. Next one is ninth question. Give suitable example and explaining this definition. We have to explain these definitions. What is ambident ligand with an example? What is a ligand? What is a ligand with an example? And what is a chelating effect and an example? What is the denticity of ligand? What is a crystal field splitting energy? What is a synergic effect? What is a spectrochemical series? That definitions we have to write. Next, another one is describe with an example and role of coordination compounds. We have to explaining that what applications of coordination compounds in biological system, analytical system and medicinal chemistry. Applications of coordination compounds. Next, using the UPAC names, write the name or formula of the following compounds. This complex compound is given, we have to write the name. Complex compound is given, we have to write the name. Next, name is given. This is formula is given, we have to write the name. Here name is given, we have to write the formula. Name is given, we have to write the formula. This is a 10th question. Okay. Next, see now by using these tips, we can solve all these questions are very easily. For suppose, if the ligand is strong field ligand, according to the NCERT book, there are order is given. According to that order, carbon donors are strong field ligands, then nitrogen donors, then oxygen donors, then halogen donors. Halogen donors are weak field ligands. For suppose the given ligand is strong field ligand, almost all the complex compounds are diamagnetic. Almost, any one or two exceptions will be there, like nickel tetracarbon. Almost all are diamagnetic. Nickel tetracarbonyl is also diamagnetic. Almost diamagnetic. Next, strong field ligand means almost no unpaired electrons. Almost all complexes will give and no unpaired electrons if the ligand is strong field. Any one or two exceptions will be there. Next one is electron. Strong field means electron pairing is taken place. Strong field means crystal field splitting energy is greater than pairing energy. If coordination compound is 4, then it is undergoing dsp2 hybridization mostly, except nickel tetracarbonyl, that is undergoing sp3. Almost all coordination compounds means mostly strong field means dsp2 square planar geometry. Next, strong field ligand coordination number 6 means d2sp3, that is inner orbital complex compound is formed. Coordination number 6 means octahedral geometry. Next, strong field ligand means almost that complex compound is more stable with respect to monodentate ligands. Okay, now the ligand is very strong, that is more stable complex compound. If the ligand is strong field, no unpaired electrons, no DDD transition, so therefore that complex compound is colorless. Okay, now these are the, whenever strong field is given, by keeping these points we can solve the questions or what directly. Because for 3 mark question they are asking, or for 3 mark or for 2 mark, they are asking what, they are giving one complex compound and they are asking what is its magnetic behavior. Directly we have to write its magnetic behavior. Next, is it paramagnetic or diamagnetic? Okay, is it color or colorless? And what is its geometry? Coordination number 4, strong field ligand means almost square planar geometry. Coordination number 6, strong field ligand means almost d2sp3 hybridization and inner orbital complex and octahedral geometry. This is with respect to strong field. Next, weak field ligand means opposite points. Strong field opposite is called as weak field. Weak field means unpaired electrons is present, so magnetic moment is more. An electron pairing is not taken place, so more unpaired electrons are present, more is the magnetic moment. Weak field ligand means crystal field splitting is what, less than that what, pairing energy, less than the pairing energy, so therefore here pairing of electrons won't be taken place. Coordination number 4 means sp3 hybridization tetrahedral geometry. Coordination number 6 means sp3d2 hybridization octahedral geometry. Now generally the complex compounds which are containing weak field ligand, they are less complex. Okay, by using this in a given complex, first we should identify the given ligand is strong or weak. If strong means follow these points, if weak means follow these points. Okay, 1 or 2 exceptions will be there. Next, another one is by using this tables also is going to be what, help you to calculate the oxidation state of central metal atom, to calculate the to find that what the ligand is monodentate or bidentate or tridentate, like that we can easily guess by using this table. Mostly repeated ligands, these only in the examination. Okay, now what is the neutral ligand? Coordination number 1, oxidation state 0. Next, ammonia, coordination number 1, oxidation state 0, neutral ligand. Ethylene diamine is a neutral ligand, coordination number 2. One ethylene diamine means it is having 2 donor sites, so therefore denticity is 2. Coordination number is also nothing but density. Density means number of donor sites in a given ligand. Ethylene diamine, it is having 2 donor sites, so therefore its density is what? 2. Coordination number is 2. Oxidation state 0. Carbon monoxide, coordination number 1, density is 1. Oxidation state 0. Cyanide, density is 1. Oxidation is -1. Thiocyanide, density is 1. This one. Halogens 1, oxidation state -1. Next, oxalate, C2O4 2 minus. Coordination number 2, oxidation state -2. Sulfate -2, nitrite -2, nitrate -1. Sorry, nitrite is also -1. Nitrate -1, nitrosoil +1, coordination number 1. Oxalate coordination number is 2. This sulfate also coordination number 2. Next, what is ambidentate ligand? Cyanide, so NO2 minus, thiocyanide SCN minus. They are the ambidentate ligands. Ambidentate ligands means they are having 2 donor sites, but only one atom only donating the pair of electrons to central metal atom during the formation of the compound. Okay, by using these tips, you can solve that coordination complex compounds questions are very easily. Okay, practice this top 10 or 11 questions, maybe it will help you. Thank you. If you like these questions, please subscribe the channel and like the channel.